Hello and welcome, students. I'm Kayla, one of the virtual teaching assistants for your professor of psychology, Jeff Hastings. In this video, we'll break down the major concepts, definitions, and key terms discussed in Chapter 1 of your textbook, Psychology in Your Life, by Sarah Grisson and Michael Gazzaniga. Let's dive in. What is psychology? Psychology is defined as the scientific study of behavior and mental processes. This chapter helped us understand that psychology isn't just about diagnosing mental disorders. It covers a wide range of topics, including how we learn, remember, perceive the world, and interact with others. Behavior refers to any observable action, whether it's speaking, walking, or blinking, while mental processes include thoughts, feelings, and motives that aren't directly observable but can influence behavior. For example, when we discuss someone's emotions or reasoning, we're referring to mental processes. Together, psychology seeks to understand how behavior and mental processes work, how they develop, and how they can be changed. Psychologists study human behavior from various perspectives, and this chapter introduced 5 major approaches. Biological approach. This perspective focuses on the physical structures and biological mechanisms that influence behavior and mental processes. It emphasizes the brain, nervous system, and genetics. For instance, researchers might look at how neurotransmitters like dopamine affect mood and behavior. Behavioral approach. Pioneered by figures like John Watson and B.F. Skinner, this approach focuses on observable behaviors and how they are learned through interaction with the environment. Terms like conditioning and reinforcement are central here, and it largely ignores the internal mental state in favor of studying outward behavior. Cognitive approach. This perspective deals with how we think, remember, and perceive the world. Cognitive psychologists study processes like memory, problem-solving, and decision-making. They might ask questions like, how do people store and retrieve memories? Or what influences our decision-making in complex situations? Humanistic approach. Associated with Carl Rogers and Abraham Maslow, this approach emphasizes personal growth and free will. It looks at how individuals strive to reach their full potential and focuses on concepts like self-actualization, the idea that we all have the potential to be our best selves. Psychoanalytic or psychodynamic approach. Originating from Sigmund Freud's work, this perspective focuses on the influence of the unconscious mind and early childhood experiences. Key concepts include the id, ego, and superego, which describe different parts of our personality that are in constant interaction. We also learned about the scientific method, which is the process psychologists use to conduct research and gather data. It involves several key steps. Observation. This is the initial stage where a researcher notices a phenomenon or behavior that sparks interest. For example, a psychologist might observe that some students perform better on exams after a good night's sleep. Research questions. From the observation, researchers formulate specific questions they want to answer. These questions guide the research process. In this example, a possible question might be, does the amount of sleep affect academic performance? Hypothesis. A hypothesis is a specific, testable prediction based on the research question. It usually proposes a relationship between 2 variables. In our case, the hypothesis might be, students who get more than 8 hours of sleep before an exam will score higher than those who get less. Experiment. To test the hypothesis, researchers design an experiment. This step involves manipulating the independent variable, in this case, sleep duration, and measuring the dependent variable, exam performance. Researchers must also have control groups to ensure that the results are due to the manipulation and not other factors. Analyze data. After conducting the experiment, researchers collect and analyze the data. They use statistical methods to determine whether the results support or reject the hypothesis. For instance, the analysis might show whether students with more sleep consistently performed better on exams. Report results. Finally, researchers report their finding in academic journals or other outlets. This step is crucial because it allows the scientific community to review and replicate the study. In this case, if the results support the hypothesis, the conclusion might be that sleep improves exam performance, offering valuable insight into student well-being. Now that we've covered the basics of the scientific method, let's take a closer look at some key research terms and concepts that are central to understanding how psychologists conduct experiments and studies. First, let's talk about variables. In psychological research, a variable is anything that can change or vary. There are 2 main types of variables that we focus on. Independent variable. This is the variable that the researcher manipulates or changes to see if it has an effect. For example, in a study on sleep and exam performance, the independent variable would be the amount of sleep students get before the exam. Dependent variable. The dependent variable is what the researcher measures in the experiment. It's also referred to as the outcome variable because it's the outcome of interest that may change in response to the independent variable. In our example, the dependent variable would be the students' exam scores. There are also extraneous variables, which are factors that researchers find that could be affecting the outcome that they did not account for. By controlling these variables, researchers can isolate the effect of the independent variable on the dependent variable. Psychologists use different types of research designs, depending on what they are trying to investigate. The three most common types of study design are descriptive studies. These studies are used to observe and describe behavior without manipulating variables. Examples include case studies, naturalistic observation, and surveys. In some cases, where researchers cannot control the environment, a descriptive study may be the only type of study that can be performed. Descriptive research helps us understand what is happening, but it doesn't tell us why or how behaviors are related. Correlational studies. In correlational studies, researchers examine the relationship between two variables without manipulating them. A key concept here is that correlation does not imply causation, meaning just because two variables are related, it doesn't mean one causes the other. For example, there might be a correlation between the amount of sleep students get and their exam performance, but that doesn't necessarily mean that more sleep causes higher scores. Experimental studies. In experimental designs, researchers manipulate one or more independent variables and measure the effects on the dependent variable. This type of study allows researchers to determine cause and effect relationships. For example, an experiment could randomly assign students to either get 8 hours of sleep or 4 hours, and then test their exam performance to see if sleep caused differences in scores. A key term you'll encounter in correlational studies is a correlation or correlation coefficient, which refers to the relationship between two variables. Correlations can be positive or negative. A positive correlation coefficient means as one variable increases, the other also increases. For example, there might be a positive correlation between study time and exam scores. More study time is linked to higher scores. If the correlation coefficient is negative, as one variable increases, the other decreases. For instance, there might be a negative correlation between stress and sleep. More stress is linked to less sleep. The strength and direction of a correlation are measured by the correlation coefficient, represented by the letter R. The correlation coefficient ranges from a -1 to a +1. A value of +1.0 indicates a perfect positive correlation. A value of -1.0 indicates a perfect negative correlation. A value of 0 means no correlation. If asked a question about the strength of a correlation, it's helpful to draw a line similar to the one below me. The closer the point on the scale is to 0, the weaker the correlation. The closer the point is to a 1 or -1, the stronger the correlation. For example, if the quiz asks you which correlation is stronger, a negative correlation of 0.8 or a positive correlation of 0.3, the answer would be -0.8 has a stronger correlation than +0.3. Finally, it's important to remember that correlation doesn't prove causation. For example, just because sleep and exam performance are correlated doesn't mean that sleep directly causes better scores. There could be other factors involved. Before we conclude this chapter summary, I would like to mention a few other topics that are important to know. In experimental research, two key factors help ensure the validity of the results: random assignment and random sampling. Random assignment is the process of assigning participants to different groups, such as experimental and control groups, by chance. Random assignment helps eliminate biases and ensures that the groups are similar, so any differences in the outcome can be attributed to the independent variable. Random sampling refers to how participants are chosen for a study. In a random sample, every member of the population has an equal chance of being selected. This helps ensure that the sample is representative of the larger population, making the results more generalizable. In an experiment, researchers often compare two groups. One is referred to as the experimental group, and the other as the control group. An experimental group is the group that receives the treatment or manipulation of the independent variable. For example, if we're studying the effect of sleep on exam performance, the experimental group might be required to sleep for only 4 hours, the night before the exam. A control group refers to the group that does not receive the treatment or is given a neutral condition. In our sleep study, the control group might be allowed to sleep as much as they want. This comparison helps researchers determine if the independent variable, in this case, sleep restriction, has any effect on the dependent variable, exam performance. Now, let's talk about placebo effect and double-blind procedures. When conducting experiments, researchers need to account for the placebo effect, where participants' expectations can influence their behavior. For example, if participants believe they are receiving a treatment, they may experience changes even if they're given a placebo, which is an inactive substance. To minimize bias, researchers often use a double-blind procedure where neither the participants nor the experimenters know who is in the experimental group or the control group. This helps prevent both participants and researchers from unconsciously influencing the results. Finally, it's important to remember that all research must be conducted ethically. This means following the principles of informed consent, confidentiality, and debriefing. Informed consent means participants must know what the study involves and agree to participate. Confidentiality means that researchers must protect participants' private information. After the study, participants should be debriefed, which means they should be told the purpose of the research and any deception used should be explained. Ethical guidelines ensure that psychological research protects the rights and well-being of participants. To sum up, understanding key research terms and concepts, such as variables, study designs, correlation, and experimental procedures, is crucial for understanding how psychology gathers and evaluates evidence. By following ethical guidelines and using rigorous research methods, psychologists can uncover important insights about human behavior and mental processes. Well, that's it for now. Thank you for listening. Stay tuned for our next video on Chapter 2, The Role of Biology in Psychology.